Hello, I'm George Malin, the Managing Editor of Vanilla Plus, and welcome to today's webinar. In the aftermath of last week's Mobile World Congress, there's a lot of excitement about 5G, which is edging further into the spotlight as CSPs continue their preparations for commercial launch. A critical component of this preparation is the policy, rules and charging function, which today's webinar will take a closer look at as we explore data strategies for 5G. I'm delighted to be joined today by two speakers. First, we have Robin Duke-Woolley, an analyst and the CEO of Beecham Research, who will set the scene before handing over to Dheeraj Ramella, the Chief Technologist at VoltDB. Both speakers will also participate in the Q&A session after their presentations, so I'd urge you to take advantage of this opportunity by entering any questions you have in the panel on your screen. I'll put as many of those as possible to our panelists after their presentations. Finally, before handing over to Robin, I'd like to take a sounding of where the audience is today in terms of your PCRF migrations to 5G. I'll do this in a form of a poll, so there's now a question in front of you, and if you can select one of the possible responses, we'll be able to get the results nearly instantly. So the question is, where are you with your PCRF migration to 5G? And the options are not yet started, you're in the planning stages, the migration is in progress, or finally, the migration is almost complete. I'll just read the questions and answers one more time. The question is, where are you with your PCRF migration to 5G? And the possible responses are, not yet started, in the planning stages, the migration is in progress, or the migration is almost complete. Let's see what the results are. And unsurprisingly, given the early stage of 5G deployment, the majority have not yet started your PCRF migration, that's 60%. But encouragingly, the planning stages seem well advanced with a quarter of respondents saying that they're in those planning stages, and a further 15% have already started, so that's good. Unsurprising that none of you have almost completed. That's very interesting. So without further ado, I'll hand over to Robin Duke-Woolley. Robin, the floor is yours.
Thank you very much, George. Okay, so I'm just going to give a very brief overview of 5G as we lead into Dheeraj, who's then going to go much deeper into PCRF. So as this chart shows, and as a brief introduction to 5G, 5G is not all about increasing bandwidth, enhanced mobile broadband, but it's a collection of technologies, so ultraband, small microcells, and machine-type communications. And key areas within this are network slicing, mobile edge computing, cloudification. Dheeraj is going to say a lot more about network slicing shortly. And things will arrive at different times depending on development in these three main areas. So to take one of these, network slicing, for those of you that are not familiar with that, what is it? It's a particular feature of 5G. It allows a network operator to provide dedicated virtual networks with functionality specific to the service or customer over a common network infrastructure. So each virtual network can then be customized to meet the specific needs of applications, services, devices, customers, or indeed other operators, MVNOs and so forth. So we think that's likely to have a very significant impact on vertical markets in IoT, with networks optimized to the specific requirements of a set of applications. So on the one hand of the slide, on the left-hand side, we have massive machine-type communications. And under that heading, we've got typical applications like smart building, logistics, tracking and fleet management, smart metering, agriculture. And there we're looking at very low cost, typically $5 per annum, or maybe even less now than that after Mobile World Congress. We've got greater than 10 years battery life, very low data volumes, massive numbers. Typical numbers are 40 devices per household, extended coverage, and then moving to support 1 million devices per square meter. So a very large number of devices out there, particularly in urban locations. On the other hand, on the right-hand side, we've got ultra-reliable and low-latency communications, where 1 millisecond latency is the aim. So examples of that, we've got virtual reality and augmented reality at 7 to 12 milliseconds latency. We've got tactile internet, so for example, remote surgery, remote diagnosis, remote sales, less than 10 milliseconds latency. And we've got V2V, vehicle-to-vehicle, cooperative driving, platooning, collision avoidance, less than 10 milliseconds. And then we've got manufacturing and robotic control, safety systems, less than 10 milliseconds. So we've got those combinations. If we then move over to a specific example, we've got network slicing for cars on this one, which is autonomous car will rely on vehicle-to-anything communication. So that includes vehicle-to-vehicle, vehicle-to-infrastructure, vehicle-to-network, vehicle-to-pedestrian, so forth. And that requires low latency, but not necessarily high throughput. On the other hand, a streaming service watching a car will require a high throughput, but not so concerned about latency. So the opposite. Both will be able to be delivered over the same common physical network on virtual network slices to optimize use of that physical network. So for 5G, we have the Cooperative Intelligent Transport System, or CITS, whose aims are testing, standardization, building commercially viable business models, creating new applications and services. And there are a number of outstanding issues to be addressed for 5G. We have pan-European regulations, for example, release of new frequencies, real estate of base stations, where should they be, what sort of business model should they have, security, privacy issues, and country network characteristics. And then that gives us, if you like, an idea of what 5G will deliver in a nutshell. It does mean major changes to telcos to implement. So a key question for us here is how a telco is going to fund 5G investments and monetize their investment. PCRF, we think, is an essential part to help telcos make 5G a success. And Dheeraj from VoltDB will now tell us more about how this is going to be achieved. So over to you, Dheeraj.
Thank you, Robin. And thanks, everyone, for joining this session where we're sharing our thoughts and learning with this gathering. So I am the Chief Technologist at VoltDB. VoltDB is a database that has been primarily attuned for carrier-grade performance, and we work with a lot of telco organizations. So from that experience and going to the Mobile World Congress and firsthand working with telecom organizations, there are a few learnings that we brought together, right? So what is happening in telco and what is the primary concern going forward towards 5G? So in this session, what we're going to do is we look at 5G objectives, as Robin has laid out earlier as well, and tie that to what are the things that are necessary to happen in the underlying infrastructure to satisfy and meet those needs, right? So when you look at it, like the current world is 4G, EPC, VEPC, which is the Evolved Packet Core, and then you have the 5G Next Gen Core. So what is that journey going to look like, right? So, and one of the main components that need to evolve from where it is today as a PCRF to an all-encompassing policy control module as PCF into the 5G NG Core world is to meet the objectives that you see, probably a million times by now. So what are the objectives of 5G? Speed, low latency, scale, and complexity. So the speed being the mobile broadband, and the latency requirements is because it's going to be a connected world that 5G is catering to. You are going to be driven by timeouts and APIs and machine-to-machine interactions, and in those cases, they're all going to be low latency communications. You take less than 10 milliseconds from UE to core, the user equipment, to the network core. Once the data arrives into the core, then what do you do with it, and how fast can you do it? Because you're already consuming 10 milliseconds, right? So beyond that, how fast can you get to a valid decision that's going to materially affect the interaction, right? So and this has to be done at scale. When you look at the subscribers, the subscribers are a net zero sum game, right? So if you zero sum game, that's the term I was looking for. So because if you look at it, the people population does not explode spontaneously. While bringing in an industrial Internet of Things implementation into the network would immediately start putting a lot of signaling load in a surge. So one of the goals, as Robin mentioned, is the 1 million devices per square kilometer. When you have that kind of high density deployment, not all these devices are a specific account, right? So these devices have their own policies, per device policy, per cluster deployment policy, and per implementation policy. So when you look at all these complications that arise from this, what does that do to the underlying infrastructure? Of course, there's something that enamors me about the 5G objectives is the million slices, right? So network slicing in some form or other has been there. The latest avatar is the APN, right? So the access point names. If you take your phone and go to settings and actually look at what is the access point name, it usually is your carrier name. So what does that translate to in today's world is when you're roaming and you're actually coming in with that APN, and the roaming provider that's actually catering to your services locally is going to look at the APN and say, like, okay, I'm going to allocate some bandwidth for this because I'm contractually obligated to. But think of, fast forward 2 years from now, right? Think of the hundreds of use cases, and by then it'll be thousands of use cases that are relying on the infrastructure that a telecom operator provides. Given the confluence of fixed and mobile networks coming together, the convergence of it, you're going to see a lot more use cases that are going to leverage the networking. And when you have 1 million slices, these 1 million slices are not all independent either, right? So there could be occasions where you're service chaining, and that service chaining could be catering to inter-slice communication. So we'll talk about it a little bit later. So these are the general objectives. So where are we today, right? So I think one of the questions that came in while we were starting is, how can you migrate to 5G when it's not yet defined, right? So it's an interesting conundrum. So the way 5G is being done is they've broken it up into 2 phases. The first phase is non-standalone, where you are purely looking at the infrastructure speed of it, and that's going to rely on the 4G core systems, right? So that's your first part of it, the phase 1 of 5G, and that's already in progress. Like, I mean, you can go to any news website or ask Dr. Google, like, who announced the latest 5G deployments in cities in the U.S. You'll see Verizon, AT&T, T-Mobile. I think the most latest is John Laguerre from T-Mobile announcing 50-city target list for 5G implementation. So while it's socially called as 5G implementation, the underlying fact of it is it's the phase 1 of 5G, right? So what is phase 2? It's end-to-end cloud native. So that's the nirvana, that's the Xanadu that we're all vying for. So when you look at cloud native, what does that mean? Now, you're looking at virtualizing every layer of the communication stack so that you're able to scale with much higher agility. It's a very lofty goal, but there is a path to it, and you can see that. I was at MWC on a panel for 5G reality check, and there's a gentleman from University of Surrey who heads the 5G Innovation Center there, and they have actually put together a 3-site test center, which is end-to-end 5G spec based. Right, so it's not publicly done, but it's actually evolving along with the specification evolution as well. Right, so I'm thinking it's going to be, I think, Q3 or Q4 2018 is when the phase 2 specs are going to be kind of semi-solid, and you're going to start seeing implementations into 2019. Right. So today they're actually parallel feeding from the packet core, parallel feeding between the 5G nodes and the evolved node piece. Right. So, and eventually it's just going to be the 5G nodes where you're co-locating your E node and RAN together, and thus decreasing the latency. It's all going towards the ultra reliable, low latency communication. Okay. So what does this do to PCRF, which is, the spotlight is on PCRF in our discussion today. So we'll just focus on that elements of it and neighbors, right? So PCRF is going to become policy control function. So it's going to have a broader perspective, because it's not just simple OSS style policies anymore, right? So you're going to have policies that are actually driving beyond your operations into a realm of dynamism, so to speak, where your rules and policies that need to be applied on the incoming traffic can dynamically be created, modified, updated, or removed, as the case may be. Think of the database term CRUD, right? So creating new entities, updating them, reading them, and deleting them. So all of these are going to apply towards the policies, given that it's all going to be software enabled going forward. So some of the opportunities that we're going to be able to leverage when 5G is coming into play is fixed mobile convergence and dynamic backhaul policies for IoT use cases. When you look at IoT use cases, there's going to be a heavy influence of machine learning of what these rules and policies should be. So every cycle of machine learning completes, you're going to have a new set of rules that are going to be dynamically updated in your policy control layer. So then, now you're to one of the points that I mentioned earlier, right? Like, so not only are the things and IoT going to be getting new policies, the operators are going to be able to create new products for their subscribers, where the subscriber is able to introduce policies on their per account basis. A colleague of mine, I work very closely with him. He always says, like, I wish, like, when I'm traveling around the world and I need mobile hotspot and things like that, I throttle down my daughter's Facebook consumption so that I have better service. So, and it's time bound just for my travel. And it's a really interesting use case. Now, I don't know if that's going to be done or not, but going forward, you would have the ability to create such a product wherein the subscriber himself is now intervening into the system and asking the system to treat his or her traffic by his or her rules, right? Now, one of the things that that's front and center in my mind, and as well as the industry's mind, is the security. When you're putting together such a high-speed network, you have to have security as a pre-built, built-in, part from the day one kind of an implementation. You cannot actually slap in. An example that an analogy someone actually says is like, I want to make an apple pie. You don't make a pie and then like slap apples on it, right? Like, so you bake it with the apples in there. So when you look at security, the security is not role-based access control or rule-based access control even, right? So it's policy-based access control. And these policies are going to be not just static, the dynamic elements of it come into play when you're learning from machine learning what is the kind of fraudulent activities that can happen, what is the blacklist, what is the whitelist, and then new entrants come into your network. You have to update your whitelist. Within the whitelist, what is the begin to end connectivity policies? What is the allowed route, black route, white route, gray route? All of these kind of policies come into play. So you need to have a tighter integration between PCF and your DPI, the deep packet inspection layers. Right. Now, one of the things that Robin mentioned is really, strike the chord for me from our exposure as well is all of this infrastructure capabilities that you build towards 5G is going to be a very clever experiment if you are unable to monetize, right? So you don't want this whole new wave of innovation to be a cost center. You want it to be a revenue center. How do you monetize on it? So the operators themselves are becoming more and more pipelines. So how do you make this pipeline intelligent? And it's via partnerships with OTT, right? The over-the-top providers. Take, for example, I don't know, I'm assuming a lot of the folks are actually international, so I'm not sure if you know of it or not, but T-Mobile has a program called Binge On. By the way, this is just examples. I don't work for T-Mobile. I don't have any contract with T-Mobile. Just throwing out some examples there, right? So the Binge On example is Binge On is where T-Mobile and Netflix have a partnership. So now within the core of TMUS, they are able to look at the packets and say like, okay, this is Netflix packet, so it's not going to count towards my online charging, towards the data consumption because it's Binge On traffic. On the other hand, if it's Facebook or if it is something else, then it's going to count towards the general consumption of the data plan, right? So these kind of capabilities, while they're there, the complexity that comes with 5G is the slices, scale, and the ultra-low latency at the kind of speeds that EMBB would actually want to avail to the subscribers and networks. One of the interesting features that I wanted to bring up here is the UDF, is the Unified Data Function, which is something that some of our customers are already putting into play in Europe. Is it's to when you're going into a VNF world and when you're actually doing containerization of your functions, in that case, you need to have a common data repository that all these functions are able to look at and have a single version of the truth. Because this becomes important from when you look at the AAA or OCS and the authorization, authentication, accounting, and the online charging. These functions need to look at the same exact version of the data. But if you take this end-to-end containerization and you want to scale that way, you're going to start looking at into data discrepancy challenges. So how do you address that at the scale? The UDF is a perfect answer. You want to have a common data repository and a unified data function that's actually an interface to everyone that needs to look at a subscriber's related data and policy. So these are the three major things that we're actually observing as the front and center in operational decisions driven by policy. Security and identity management, we talked about that, right? So the blacklist, whitelist, black channel or black route, white route, and gray route. I don't know if you guys know the black route, white route, and gray route. Essentially what it is a white route means the origin is legal and the destination is legal of this, IP packet transfer. So on the other hand, a black route is origin and destination are illegal. Now gray is one of them is legal, one of them is illegal. So these are all things that are necessary. Like if you look at it, like the compliance, the regulatory mandates, and being able to report to the national security, local national security agencies, be it CIA or FBI, whoever be it, being able to report on what kind of traffic it's traversing is important, because for people to come into your system, you need to give the confidence that it is a secure system, secure network, right? If you don't have the necessary capability to handle the security needs at scale, it's going to become apparent very quickly, right? The second element is the machine learning part of it. We talked about it briefly, but there is a lot of cross-pollination of ideas between a variety of industries, especially in the machine learning realm, because every good thing that gets done, there are 100 people that want to break it and use it for a bad effect, right? So how do you, it ties back to the security. How do you actually continually enrich and refine the rules and policies you're applying towards detecting fraud, anomalous behavior, or interesting behavior even, or health deterioration in the deployment of, power systems or windmill turbines and things like that, right? Like, so in those kind of deployments, it's health telemetry of the instruments in play, and you want to be able to learn very quickly what is happening, what is it indicative of. If something is bad going to happen, then what do I do to remediate the situation before the system shuts down, right? So when you look at the bigger picture of this, like, you are learning a lot from your big data and continually getting retrained with the new training data at the machine learning layer. But how do you actually integrate that into an operationalization layer while maintaining your low latency and scale promises that 5G makes, right? So that's where you need a data platform that's able to marry the outcomes of your machine learning into your policy and policy-based decision-making layer, right? Then, of course, the real-time tariff calculation, it's a wild west at this point when you look at industrial IoT, versioning into the scenario. It's wild west in the sense that, not craziness element of it, right? It's more of there is a lot of opportunity that people can do very creative tariff rates and charging. It could be contractual, it could be policy-based, it could be tier-based, it could be the guaranteed bit rate-based. So you can think of any number of combinations of these capabilities playing together in an environment where you're able to come up with creative tariffs. So all of these are getting encapsulated in the PCS, OCS, UDS layer, where you're using a single source of truth, applying complex policies, learning from machine learning, enriching the rules and policies, and be able to charge accurately. Right? That's the monetization part of it that comes into play. Okay. So we'll look at a couple of elements that are actually going to drive a lot of policy changes. When you look at service chaining and network slicing, this element itself is going to be very, very interesting, because you have the guaranteed resource slices wherein you already have allocated a slice of your bandwidth and the resources that go underneath it towards a specific use case. Now, what could become interesting is the dynamic multi-tenancy, right? So when you look at what is happening to telco, it's what happened to data centers 10 years back, 15 years back, right? So when the whole cloud computing started becoming front and center, data centers actually went into the multi-tenancy model of cloud computing. All of that learning can be brought into the telco world, which is heading towards a cloud-native core anyway, right? So the analogies and learnings are very, very congruent and contextual. So when I'm thinking about multi-tenancy slices, what am I talking about? It's essentially, you have a slice that's available for anybody that says, like, okay, I have lenient SLAs, just essentially club together slices that would match to my performance needs at the moment. And it's dynamically scaling up and down as the needs be, and be able to charge accordingly. So it's almost like a pay-as-you-go kind of a model, but on the resource allocation. So it's something that I've been actually thinking about. I read a few elements of such thinking in other leaders' space as well. So it'll be interesting to see how it manifests when it really comes into play. So now, when I'm talking about slices, it's not just the bandwidth slice, right? So the underlying infrastructure and the underlying core components also need to participate in these slicing policies. Now, if you look at the example that I have here, right? So mobile broadband slice. So you have radio, RAN, and the gateway all participating together. In IoT, you have the higher layers of RAN, which is specifically for IoT. The massive machine type communication type RAN layers. In the low latency slice, you have guaranteed bit rate and you have higher performance network components that enable the 10 milliseconds air to core guarantee being met. So all of this comes into play in both the OSS side and BSS side, because you have to do all of these things as fast as you can. If you look at the whole CUPS movement that's happening, which is essentially the control plane and the user plane getting disaggregated so that your user plane stays closer to the RAN, so you're able to provide the value to the user as fast as possible to meet the ultra reliable low latency communication guarantee. So million devices per square kilometer, right? So this is the elephant in the room, the industrial IoT, autonomous cars, vehicle-to-vehicle communication, vehicle-to-cloud communication. What do we do with this, right? So can 5G help there? I think it would be, I don't know how to say it, like maybe the word is irrational to think that all the data generated by all the devices are all going to use 5G to traverse. The reason I think that would be irrational is in a typical industrial IoT scenario, if it's distributed deployment, then 90% of your data is system normal, right? So then the 10% of anomalies need to be detected at multiple layers. So you can think of your IoT implementations as edge computing, fog computing, and cloud computing. So, and there's decision-making layer that needs to happen at each of these levels. So the cloud layer would be your actual EPC or next-gen cloud-native core. So, but what about the vehicles? The vehicle-to-vehicle communication and vehicle-to-cloud communication. But one of the examples that I saw at MWC is you have multiple cars on each individual lane in a street, and you have the traffic lights that are belonging to a certain network, or perhaps a fixed network. Now, you need all these cars to talk to each other and also talk to the traffic lights to understand what is going to happen so that they can preemptively stop braking or accelerating, whatever be the case, right? So, and this leads to a thinking and thought process of the cooperative computing, like Robin mentioned earlier, wherein you shouldn't be needing to go out to the cloud for all decisions. And you'll see that in Tesla implementations. There's a lot of onboard computing, a lot of onboard decision making. Once you are done with that, then you're actually sending data periodically to the cloud to garner the data that's necessary for enriched decision making going forward. Very similar to that, your in-the-moment decision-making in connected car and vehicle-to-vehicle communications needs to happen on the road. So you would have, it's almost like, think of like LTE Advanced, what LTE Advanced is doing, right? So the private LTE kind of deployment. You would have localized cell-based communication where the communication just goes to the cell and comes back, or the communication goes to on-street an aggregator and comes back. So when you look at this kind of scale of million devices every square kilometer, you need to have to tier your policy application at various layers, synonymous to what in the cloud data center and cloud computing world is the edge, fog, and cloud computing, right? We talked about security requirements. Security requirements, again, to reiterate and re-emphasize, so to speak, it has to be thought of from the beginning and not slapped on as a facet of that can be added later on, and everyone communicates to it, right? So, excuse me. So, what is the journey to the next generation network core, the cloud native core, right? So it's the end-to-end software-driven everything. So we already have the SDN, SD-WAN, VEPC, the virtualized network functions. All of this is already happening, and I think the next step that people are looking at to make sure that happens is vRAN, the virtualized RAN, the radio access network. So when you actually mimic and bring in all of the hardware capabilities that are in play into a software-enabled world that are deployable on commodity service, you arrive at a place where end-to-end is virtualized and cloud-native. So towards that goal, you basically need to have software stack that is all cloud-ready and built for agility and scale, right? So without that, there are some technologies that are being used. I'm trying really hard not to name names here in this instances. At least from working with our customers, we've seen that some of them used to have elements of data processing and decision making in their stack that was not synchronized with the thought flow of going cloud native, right? So which is when they actually came to VoltDB, and so it's important for this transition to be successful that choices be made to pick the right technology to do the right thing. There are several options out there, but the due diligence is necessary, right? So move on to the next one. So why am I a database company's chief technologist talking about so much about telco is essentially what we have observed and what we map from VoltDB's capabilities into what is the 5G readiness objectives, right? So when you look at the scale and cloud native architecture and the complex rules needing to be applied as soon as your event arrives into the core, we have facets and facilities and capabilities within VoltDB that allows us to uniquely solve those challenges as observed by our customers. So this is the plug slide, so you can pretend like you didn't hear me. So that's all I have. So at this point, I'm just going to open it up for George to take control back and go from there.
Thank you, Dheeraj. That was really good. I found that really interesting. Before I open the floor to questions from the audience, we've got one more poll that I think will be interesting for us to do. So here's the question. What is your main concern about the future needs of PCRF? And the options are security, applying machine learning, low latency decisions, or the scale of IoT. So I'll read those once more. What is your main concern about the future needs of PCRF? Is it security, applying machine learning, low latency decisions, or the scale of IoT? And let's see what the findings are. And I guess that's probably not very surprising that security is the greatest concern, almost a third of you selecting that. Quite interesting also that the scale of IoT and the challenges of applying machine learning were selected by a quarter of you. So I think that's some interesting food for thought. Now let's turn to the questions that we've had. I'm very pleased we've had quite a lot of questions in from the audience, and there's still time probably for a few more to get answered. But Dheeraj and Robin, I'll start with a question that's come in. The question is, do you see the unified data function becoming more than just a subscriber profile repository? Dheeraj, what's your view on that? I think we may have lost Dheeraj. Robin, are you still on the line?
Yes, I am. He might have gone on mute, but it's really a question for. Yep.
Yes, I thought I wasn't going to ask you that question, Robin. Dheeraj, the question is, do you see the unified data function becoming more than just a subscriber profile repository?
I do, right? So the subscriber profile repository is the starting point of it, giving a common data repository for all the VNFs, the virtualized network functions. But the unified data function could also be an API-driven layer wherein all your interfaces to the remaining systems, such as PCRF and OCS, are all essentially codified into API, where it becomes a service-oriented architecture, right? So loosely coupled agility for scaling. Now, there is an opportunity there. This is something that, just my plain thoughts. There is an opportunity for tighter coupling between the repository functions and the layers that are using these repositories. If we can actually figure out the balance of data-driven decision-making logic and pure policies and rules kind of a thing. Like, where do these policies and rules reside? Because to truly scale, you want to keep and meet the low latency requirements. You want to keep the data and processing together. So there is an opportunity for tighter coupling between the UDF and PCRF. Now, whether that's going to placate the specifications needs, that's something up for grabs at this point. But I do see the UDF becoming more than just a repository.
Great, thank you, Dheeraj. Another question that's come in is, will the use of multi-access edge computing affect PCRF? I don't know which of you would prefer to answer that, but it's clearly that edge computing is going to have a substantial effect, I would guess. Dheeraj, what's your view on that?
My view is yes, because anytime you're actually adding a new protocol of interaction, then there is going to be necessary security rules, necessary interaction decorum rules and policies that are going to come into play. So I do see it affecting the PCRF. Now, how exactly? It's up to determination at the point of implementation, I would say.
Mm-hmm. Yeah, excellent. Next question.
Do you have any comments on that?
Yeah, sorry.
Sorry.
No, I don't.
Robin to see it yet. Okay.
Yeah,
okay.
No,
next that's come in is do you believe some of the core 5G functions will need to have an instantiation per slice in a network sliced environment, or what type of architecture do you see if that's not going to be the case?
So this is a really interesting question, and it goes back to the end-to-end virtualization cloud nativeness, right? So when you look at core 5G functions, and when you have a dedicated slice, then you have dedicated systems and 5G core function instances that are dedicated for that slice. But on the other hand, when you have,
I think we lost you, Dheeraj. Actually, could you say
we missed the first part of your answer. Shall I ask the question again, and then we can take it from the top? Apologies for the technical problems to the audience, but the question is: do you believe some of the core 5G functions will need to have an instantiation per slice in a network slice environment, or what type of architecture do you see happening? So, Dheeraj, over to you.
Okay. First, let me check. Can everyone still hear me?
I can hear you.
Yes,
okay, fantastic. Because we had snow here. I'm not exactly sure what the core network here is, but I've been actually experiencing glitches here, so just want to make sure. So when you look at end-to-end virtualization, that's going to align the implementation towards a 5G cloud-native core. You would be able to see the implementation patterns based on something that we discussed in the slices, right? So you have the dedicated slices, you have dynamic slices, and you have the multi-tenancy slices. So when you look at each individual type of these slices, now you're actually going to marry this to the idea of end-to-end dedicated resources, instances of the virtual network functions for a specific dedicated slice. On the other hand, when you have a multi-tenancy kind of a model, which is the other end of the spectrum, so to speak, you're going to have shared instances of the 5G core functions, but you would have your data model in a sense that that's able to differentiate between who is who in the dynamic tenancy.
Excellent.
If that did not answer your question, please feel free to post a follow-on question.
Excellent. I should also point out that after we're live, all the questions will be reviewed by VoltDB, so they may be able to respond to you in greater depth when there's more time, particularly for some of the more specific questions. Excellent. The next question that I've got is, what perceived challenges do you see if I am using a NoSQL database? And I guess that's one for Dheeraj.
Very point question. This is so. We recently did a very in-depth proof of concept with one of the largest telecom vendors, and they were testing us against Redis. Right? So something that actually came up is that we were equally performant, but what really started mattering is the level of consistency failures that you would see in NoSQL kind of a database. Right? So which is where this is for the database folks, so folks that are in the database world. If you hear this, and you have follow-on questions, please feel free to reach out to me. But essentially, when you look at a NoSQL database, in a highly available environment that provides continuous operations, you would observe lack of consistency. So that's something that you really, really want to be cognizant of, because the performance comes at the cost of lack of consistency, which Volt actually solved, because we're Dr. Stormbreaker's company. So for folks that don't know who Dr. Stormbreaker is, he is a Turing Award winner for computing, and he's been inventing databases for 40 years. And we are one of his inventions oriented towards high-scale transactions and low-latency responses. So I'll just leave it at that.
Okay, excellent. Another question we've had in says, it sounds like there's a lot of integration or orchestration required across all the provisioning elements, including PCRF. What should we look for to manage that integration?
So so when you look at the actual VNFs themselves, right? So you have individual organizations that are actually doing a subset of the core VNFs as independent containers. So containerization is going to be front and center. So for those of you who are not familiar with containerization, containers are really skinny virtual machines. So there's a lot of the overhead that goes with the virtual machine infrastructure, such as the hypervisors, are reduced in the number of overhead layers in containers. So this is a very key enabling technology for being able to deploy new instances of a certain function at a higher agility level. So I think being able to get your functions, the network core functions, into a containerized world and integrating those containers with a container orchestration stack like OpenStack would be highly relevant. So that would be something that you want to definitely think at the first get-go. The integration themselves, the interfaces between these layers are defined in 3GPP specs, but while there are vendors who are actually creating, for folks that are actually building themselves, you have the opportunity to have a tighter integration if you have the manpower and to build it yourself.
Sure, thank you, Dheeraj. Got another question here. It's specifically about VoltDB. It says, looking at 5G, how does VoltDB ensure fulfillment of billions of records and millions of transactions by PCRF and OCS?
So VoltDB has been actually implemented in telecom environments where we have processed over 4 to 8 billion events every day. So the billions of records is not an issue because when you look at the billions of records that are actually getting generated, they're primarily mutation of existing data, right? So you have n number of subscribers and m number of things, and these are sending their state information into your core network, and then being able to address these records and be able to apply the policies, make changes, and then report the utilization records, right, the UDRs, into the OCS has already been done with VoltDB. So, and the beauty of VoltDB is that it actually scales linearly. So when 5G hits and the higher scale levels are required, you can deploy a larger distributed computing environment with Volt to be able to process that. Hope that helps.
Yeah, excellent. Thank you.
To make it sound like a plug for VoltDB, but
yeah, it was a kind of open question, though, wasn't it? Moving on, another question that's come in is, how do you see the charging function changing with the MMTC implementation?
So this is subjective. This is my thinking. The way I actually see the massive machine type communication creating a charging environment is that you are going to have very interesting charging policies. These are, it could be per device that's going to be on the network, or it could be utilization based, wherein your devices are actually reporting, and you are saying, okay, how many devices are actively reporting at a given duration, and that duration could be your billing window, right? It could be every 5 minutes I'm going to do it, or every 1 minute, or on a streaming basis. Every time a device reports a telemetry or attempts to communicate with another device, then I'm going to charge per interaction basis. So there are going to be really interesting billing models that could actually come up into play, and I guess the most creative would have the differentiating factor for getting subscribers on. Subscribers on.
Excellent, thank you. Let's look. I think we've probably got time for maybe 2 more questions. So let's take this one. What kind of enhanced security concerns will come up with 5G implementations?
So you have, when you look at end-to-end virtualization, you have a lot of possible security breaches that could happen, right? So when you look at the NFV layer, you could actually have DDoS attacks or hijacking attacks, even the slice resource theft attacks, right? So when you look at network slicing, you could actually have someone actually that's trying to steal that slice's resources, user identity, of course, right, and penetration attacks. So when you look at all of these kind of attacks that are possible, and when you look into industrial IoT implementation now you could actually have massive signaling storms, right? So you could essentially have ping bots. I don't know if you guys are familiar or not. So when in programmatic advertisement, there are ad bots, which are essentially bots that are faking like they're actual publishers or advertisers and skimming money off of somebody. Very similar to that in industrial IoT, when you have an Internet of Things, there are thing bots that could actually start hitting your network for creating a signal storm, right? So when you look at all of these kind of challenges, there's a very rich opportunity. Well, it could be looked at as a challenge, but if you can address that, then it becomes a great opportunity for providing a secure network for your subscribers and customers. So some of the solutions that you can actually think of is the DDoS detection. So one of our customers in Japan, Sakura Networks, so they use VoltDB for just DPI-based DDoS detection. So their claim is that they've been able to detect and prevent 100% of the DDoS attacks, with VoltDB being in the middle as the packet ingestion and inspection layer, right? On the other hand, you could actually have location-based security, identity security. For identity, you're not just only looking at the AA kind of a setup where it's authentication authorization matrix, but now you're actually bringing in machine learning-based policies into looking at actual traffic from these pre-authenticated identities and figuring out if this is secure or not. So that's we can have a lot more discussion about that at leisure, I suppose, because it's a very, very rich topic.
Great, thank you, Dheeraj. Let's take one final question. The question is, with 5G Phase 2, do you see all the functionality moving to the cloud?
That is the goal, right? So I think for starting 29, it's going to be E2E, end-to-end cloud-native architecture, and once the vRAN succeeds, I think that's going to set a large momentum in that direction. So you can, I think it'll be good to be prepared for ensuring that your data layer performs at the scale of 5G in a virtualized environment, as your functions and core functions and IMS functions and VOS functions, the value-added services functions, all of these are going to start relying on this common data infrastructure. So I think it will be well advised to stop planning towards that end goal.
Great. Thank you, Dheeraj. I'm afraid we're pretty much out of time. Thanks very much to the audience for asking so many in-depth questions. And thanks to Dheeraj Ramella, the Chief Technologist at VoltDB, for spending a lot of time, which must have felt like a bit like a tennis rally, being bombarded with different questions from all extremes of this topic. But well done for stepping in and answering those, Dheeraj. That was really useful. I'd also like to thank Robin Duke-Woolley for his participation in the webinar, and of course the audience for joining in and making it happen. Thanks very much for attending today. The webinar will be available online at vanillaplus.com within about 24 hours or so you can listen to that again and tell your friends about it so they can enjoy the learnings that we've learned today. I'm George Maynham, the Managing Editor of Vanilla Plus. Thanks very much for attending today, and enjoy the rest of your day. Thank you, and goodbye.
Thank you very much. Bye-bye.